So the last video we have discussed the previous videos we discussed discretization on continuous variable and grouping for categorical variables that we can create concept hierarchy if we want to. We create a very flat hierarchy, only have one level. But you can certainly follow the same idea and create the hierarchical structure. I applied as apply, so I noticed there soon throughout the course you're going to see different apply functions, A apply, S apply, L apply, T apply, and lots of applies. So the purpose in R that we have apply is to try to avoid it have to writing a lot of loops. And apply applies one function to repeatedly to some values, either columns or rows. So all those applies are very similar on that fundamental concept of repeatedly apply a function on groups of data. And the difference really is just what input they accept and what they're going to output in terms of the data structure. So for apply, we apply this to data frames or matrix. For as apply, we apply them to list or vectors. So every one of them have just that little difference. And with usage, with practice, you're going to master them sooner or later. So I posted a link here if you want to learn more, follow the link. We have dealt with arm and age, and now let's check what other attributes have high cardinalities. The elements that may have correlations in this data set, since we have one data set, we're not merging data set. So those correlations or redundant attributes is less of concern. But when we apply different techniques to this data set, we're going to examine correlation at that time. So right now here in this set of pre-processing vectors, we're going to actually create groups and discretize. And normalization often been actually have often been integrated in the algorithms themselves. We don't have to explicitly do normalization many times. So for example, when we use support vector machines, the algorithm itself going to z-score normalize your data for you. And they're going to transform the data to hot encoding for you. So we're not going to actually do those steps here. Our goal here is just to create a clean set of data that can be used for different algorithms, and we can perform additional pre-processing steps that's specific to those algorithms when the time comes. So at this time, we try to keep the data, keep the regional data, and then maybe enhance it. So if we do this apply and see how many, so I'm applying unique to all the columns on the in this shooting data set. So we can see that state is okay and city is the one that we're going to have many values. That's probably the only high cardinality data set column that we have. So city is okay because city states creates a concept hierarchy, and there is not a very intuitive way for us to further grouping cities when we already know that which state they belong. So we'll just leave cities here. And the states, we have 51 states. Lots of typos. I apologize for that. 51 states is too many states for decision trees, and we can group them into regions. We could actually characterize those states by using other features. So we can have Northwest region and all that. But at this time, I'm not sure this additional regioning thing going to add a lot to our analysis. Instead, I'm thinking maybe the population and the poverty level might shed more lights into the datasets if we want to examine these datasets through the lens of the race. So I'm going to construct some additional properties to enhance our dataset. I found usmap package. This package contains data that have fairly recent data on state population and the poverty index. So let me call this library and look at this data set. So this we have state abbreviation, state name, and their population. And here let's do the poverty. We have the state and its poverty index. Okay, so now we bring more numerical data into our analysis, and that should suggest to you that we might need to do additional discretization tasks on those values. So I want to merge those to our state, because in our data, we also have state abbreviation. Therefore, that's my goal. And here, when we bring in those new data, we want to start to run some correlation task. We want to see whether the incident count and the population or the poverty level, are they correlated in some way? If they're correlated, then they're good information to include in our analysis. But they definitely will not be correlated to like 90 or 80%. So they're not redundant. They're correlated but not redundant. So we want those correlated but not redundant attributes in our data set. So this I first get from our shooting data, I found the count of incidents, and then I sorted so that we have this state count. We know California is the state that has the greatest incidents, and now we are create some joint data frames. We should look at the column name here. So I want to mention in the state population, the column name is abbreviation. That in our dataset, our column name is state. So we want to actually do a change of attribute name. So this line going to change the attribute name from the original abbreviation to the state for the population data and for the poverty data. So we run both and we got the name corrected. And then we can using the deep layers inner join function to join this data set, our counts, and the poverty data set using the by state. So those two can be joined by state. Now they have the same attribute name and also the same abbreviation. They can be joined. So we do an inner join. So this gives us, so now we can see we have state population, and state poverty level. Okay, state incidents, incident count, and the poverty level. And the earlier one should give us state count and population level. Okay, now we can run correlation. We can first do a plot. And when we look at this, so here we have a scatter plot of 51 states, their population and their state joint population n. So n is our incident count, and this is the population. So we can see a fairly clear linear relation here. If we do the correlation, and the correlation is going to tell us a fairly great good numbers. So it's 88, almost 89. So this correlation is very strong. We can do similar with the poverty. We can poverty also have a positive correlation about 30, but not as strong as the population. But I would like to keep them in our data set and see if it's going to enhance our analysis. So now we're going to discretize those two attributes that we just created. But here I want to do a victim population ratio and round it to the two positions after decimal points. So at this time, do I know they're going to be useful? Not really. I think they might. So that's what we need to find out in the future analysis. So here, once we have the ratio, I started to just do the equal width cut. This is a decision after also I reviewed the data and see there is no other clue that I could use. So I decided to just do a simple equal cut. We'll do those cuts. We can use clustering and try other methods here. And now we can put those data, join this with our shooting data. That creates a new our new version of shooting data where we have age group added earlier, armed type added earlier, poverty level, and the poverty victim population ratio, and the discretized victim population ratio. So now we have, I'm going to conclude this video, it's getting long. And then last, we're going to look at how we're going to handle dates.